Here are our generalized projection operators for the 2D irrep, and now we want to apply these to phi 1. So P3, 1, 1 applied to phi 1. That's 1/3. Now the OE just leaves the phi 1 invariant, as it leaves everything invariant. Then we have minus 1/2 clockwise rotation, sends the phi 1 to phi 2, minus 1/2 anticlockwise, we get the phi 3, minus sigma 1, so here it's invariant again, we get a phi 1, plus 1/2 the sigma 2 reflection, that gives the phi 3, plus 1/2 and the phi 2. And now we see that everything cancels again. We have a phi 1 and a minus phi 1 and a minus 1/2 phi 2 and a minus 1/2 phi 2, and same for the phi 3's. So it's 0. Now if we apply P3, 1, 2 to phi 1, then we know automatically that this has to be 0 too. Because if we fix the first index here, then we always extract the same expansion coefficient in the expansion of phi 1 in this irreducible basis. So if it's 0 here, then it's automatically also 0 here. Either we get a set of functions transforming in this irrep, or we get 0. Now let's look at the other two. Let's apply P3, 2, 1 to phi 1. Then we have 1/3 square root 3 over 2. So the clockwise gives a phi 2 minus square root 3 over 2. Anti-clockwise we get a phi 3 minus square root 3 over 2. The sigma 2 reflection across this axis gives us phi 3 minus, and the sigma 3 reflection gives us a phi 2. And here, I made a mistake. There's a plus here, has to be a plus here. Plus. Now we get each term twice. So here's a phi 2 term and a phi 2 term, same sign. So we have a square root of 3 and a 1 over 3 in front of it. So in total we have 1 over square root of 3, phi 2 minus phi 3. And the last one, P3, 2, 2, applied to phi 1. That's 1 over 3. And now the OE yields phi 1 minus 1/2 phi 2 minus 1/2 phi 3 plus the O sigma 1 gives back phi 1 again, minus 1/2 O sigma 2 gives us phi 3 minus 1/2 phi 2. So what's that? Now we have the phi 1 twice here, and say the phi 2, for example, we get once with a minus sign, and the same with the phi 3. So that is 1 over 3, 2 phi 1 minus phi 2 minus phi 3. And well, this is a pair of functions that transform in this 2D irrep, or they are a basis for an invariant subspace which carries this two-dimensional irrep.